So Physics 11, exercise set 1.3.2, number 1. I have a car that's accelerating from 40 kilometers an hour to 80 in a time of 5 seconds. We want to know what the acceleration of that vehicle is and how far it travels at that time. So let's see what we've got here. We're going from 40 to 80, so 40, that's my velocity initial. And 80 is my velocity final. Five seconds is obviously my time. Acceleration I want to know. And my displacement delta D I want to know. Okay. So let's get these listed out here first. So I got VI is equal to 40 kilometers per hour. VF, that's going to be 80 kilometers per hour. What else we got happening here? Time is 5 seconds. Acceleration, we want to know that. And displacement, we want to know that. No sweat. Well, first of all, we need to convert our velocities here to meters per second. So VI becomes 11.1 meters per second. VF is double that, 22.2 meters per second. Well, let's dive right into it. So, acceleration formula. Right, acceleration is VF minus VI all over T. Which allows us to take the VF, so 22.2 minus 11.1 divided by 5. And we get an acceleration of 2.2 meters per second. 2 sig figs in this question due to the time being reported at 5.0. Now displacement, if we look at that, we need a displacement equation. It uses VF, VI, T, preferably not A. And we have the VI plus VF all over 2 and all that times T. So like that. So let's see if I buy me some more space just a minute. I can move this much better. Okay, let's plug them in if you can remember them. So VI was 11.1, VF was double that, 22.2 divided by 2, and that whole thing was multiplied by T, which was 5.0 seconds. So our delta D, we plug all that in, becomes 83 meters. So that's 2 sig figs, so delta D, so I'm going to write it, equals 83 meters. And make your therefore statement at the end. Therefore, the car will travel 83 meters while it's accelerating at a rate of 2.2 meters per second squared. And that will do it. In question 2 of 1.3.2, we are looking at a car that's decelerating, so slowing down from a speed of 30 meters per second to rest, which would be 0, in 6 seconds. How far did it travel in that time? Okay, so we get a VI of 30. We get a VF of 0. And we get a time of 6 seconds. We want to know how far. So let's get things listed out here. I got a VI, which is 30.0 this time, and we're in meters per second. I've got a VF 0 and a time of 6.00 seconds. So we're working with 3 sig figs in this question. I want to know displacement. Well, displacement equation, same one. Let's do the math in blue this time. So the displacement equation is VI plus VF all over 2 times T. So let's get it out. VI is 30. 0 plus 0 all over 2 times 6, which equals 15 times 6, which is 90. 3 sig figs. Answer. Therefore, the car traveled 90 meters before it came to rest. Okay, exercise 132. Number 3, students rushing to get to physics class on time. Accelerating at a rate of 0.9 meters per second squared. Well, there's our, we already know that's acceleration. From rest, so we've got a VI. If the student starts at the opposite 20 meters away, that looks like a distance or displacement. How long does it take? That's time. T plus. Okay. Well, let's get our information put into place here. So I know VI is 0. Second, VF, I really don't know. I don't know that. I know time. No, I don't. I'm going to solve for time. That's really the one I want to know. So it's, I get confused between that and VF. I know my displacement. So it's 20.0 meters. What am I missing here? Oh, I guess that's it. Okay. So where can we go with this? If we look at our equations, we're looking for one where we can solve for t, but we don't need... Oh, I didn't put down my a. We don't need VF. I was missing something. Meters per second squared. And if we glance around at our equations, we'll see that this one here, this displacement equation, will do it. Was VIT plus 1/2 AT t squared. In this case, we know d. Let's look at sig figs over here too. It looks like 2, as we're limited by the acceleration number of 0.9. That's 2 sig figs. So that's what we're working with. So displacement is 20 equals my VI, which is 0 times t plus 1/2 a, which is 0.9 t squared. Now these cancel, or don't cancel, but 0 times t is 0. I'm left with 20 equals 1/2 0.9 t squared. So 20 equals 0.9, which is 0.45 t squared. Okay, big algebra step here. We're going to divide both sides by 0.45. How to get rid of the 4.45 on the right hand side? Does it cancel out? And I am left with t squared. And then, of course, we want to take the square root of t squared. So in the end, I'm left with t equals 0. No, scratch that. Let's clean this up a little bit. Let's show these steps for you here. So rather than do the math, I'm going to leave 20 over 0.45 equals t squared. And if we solve that just for t, we're going to have the square root of 20 divided by 0.45 equals t. Final answer, t equals 6.7 seconds. So therefore, takes the student 6.7 seconds to get to class. Finito. Okay, question 4, exercise set 132. This time we're throwing a ball. I've got a guy throwing a ball at speed, or a person anyway, throwing a ball at speed of 120 kilometers an hour. Let's calculate the acceleration. The person accelerates the ball through a distance of 3.5 meters. So it's like in your wind-up or whatever as you're holding the ball. So if we picture that, you could say, well, what have I got? I've got 120 kilometers an hour. That says I release the ball, so that's the velocity final. Calculate the acceleration. There's a gimme. That's A. If the person accelerates the ball through a distance, so that's a D. Delta D, I guess we're going to follow, of 3.5 meters. Okay, let's summarize these. So I have a VI, VF. Usually I have a T, maybe not this time. Delta D. Acceleration. So VI, I hesitated there because I was thinking we didn't have VI, but we do. If you're standing there holding the ball, before you throw it, the ball's not moving, so your VI is 0. And your VF is 120 kilometers an hour. have a T. We do have a D, though, of 3.5 meters. And the question is, what is the acceleration? That's what we're really looking for here. Okay. So, first of all, let's convert this velocity into meters per second. If we do that, we'll find it's 33.3. meters per second. Let's find our equation. We need one that's got VI, VF, and D, in which we can solve for A. And lo and behold, we have one here. Put it down the bottom, I guess. This is our formula, our displacement formula, which is VF squared minus VI squared all over 2A. Okay? Let's plug in our numbers. We know D. That's 3.5. VF squared. VF is 33.3. Minus 0 squared. It's an easy one. Over 2A. I'll solve for that. Okay. Algebra time. Let's clean this up a little bit. This is really 3.5 is equal to 33.3 squared over 2A. We want to get that 2A off the bottom, so we're going to multiply both sides by 2A. Those will cancel there. I'm going to get 3.5 times 2A, so it's 367.0A is 33.3 squared. Now to get A by itself on the left, I need to divide that by 7. So I need to do that on the right. So I'm left with A, because these cancel. I'm left with 33.3 squared divided by 7. My acceleration is going to equal 159 meters per second squared. Final answer. So, therefore, the person accelerated the ball by 159 meters per second squared in his windup. Complete.